Hey guys, today we are working in 1.4 where we're working on writing equations and inequalities. So again, this is about language, it's about the math that we use that's related to that language and getting those associated words to help us translate language into math. And so just looking at a couple of really classic examples here. Let's talk about some of this language that we're talking about using here. So there are these symbols here. There's equal to, okay? That's your traditional equal sign. We also have is less than. We also have is less than or equal to. And that's a case where, hey, 3 is less than 5. That's true. But I can also say 3 is less than or equal to 3. That's a true statement as well, where I'm including equality. Traditionally, less than would only mean you're either less than or you're not less than. Here we're allowed that equal, which allows us to have a little more flexibility. Then we have greater than, and last but not least we have greater than or equal to. Some of the key words that you're going to see that indicate which symbol you're to use would be like the same as or is. Okay, the same as, maybe the word is or the word equal. Fewer than is another way to say less than. So if you see fewer than or less than, those are indications that this is the symbol we want to use when we build it. At most or no more than means we're capping it at a specific number. We want to cap at that number, we're going to use the less than or equal to. Then there's more than or greater than. And then greater than or equal to might be indicated by at least. At least this amount. So we've got to be bigger, but we could be exactly the same. And so we allow that extra one in there, okay? So for the most part, this is still similar to what we worked on before. One of the big differences is that we want to be able to check our work. We want to be able to confirm when something is true. So this concept of inequality and equality allows us to check numbers. So for instance, what number plus 4 equals 10? That number would be 6, because 6 plus 4 equals 10. And so we're able to solve things like that by confirming that it makes the statement true. So right here in the very beginning, let's take a look at a couple of these problems. If we look at the beginning, 3 through 13, we're going through and we're trying to create these inequalities or equations. Some of them are equal signs, but some of them aren't. Let's look at number 8. Okay, it says the product. We learned last time that means multiplication. So we're thinking about multiplication of 4 and a number w. So I want to know, what does the product of 4 and a number w look like? Well, 4 and a number w would look like that. So that's my multiplication of 4 and w. Then it says is at most. It can be less, but it can't be more than 51. It can be equal. So I'm going to come up here if I have any question. At most, that phrase right there, at most is the less than or equal to symbol. So I'm going to come back down here. I'm going to say that 4w is less than or equal to. It can be equal to 51. It can be less than 51, but it can't be more than 51. That's what this is saying. 51. And that is what we're after on these. We want to be able to build these equations, including an inequality more often. Then down here, the next part that we really want to focus on is just how do we check to see if a number is a solution. So let's take a look at one equal sign. We'll do number 20. And then we're going to take a look at one inequality. Let's say number 23. We'll do these two problems and we'll call it good. So 20, we have k over 5 plus 9 equals 11. Then they give us a number, semicolon, they give us a 10. This tells me that this 10 should be plugged in for my unknown variable. So I'm going to have 10 over 5 plus 9. And I want to know, does that equal 11? If it does, we have a solution. If it doesn't, we can reject that. Now, following PEMDAS, we're going to have to do this division. 10 divided by 5 is 2, plus 9 Does that really equal 11? The answer is yes. So we would say that this is a solution. 10 was a correct solution to the equation given a number 20. Let's look at 23. It has 15 minus 4y is greater than 6 when our y is 2. So we're going to plug this 2 right in for our y. Gives us 15 minus 4 times 2. And we want to know, is that greater than 6? We've got to find out. Doing PEMDAS, we have 15 minus 4 times 2 is 8. We want to know, is that greater than 6? 15 minus 8 is 7. Is 7 actually greater than 6? The answer is yes. So this would again tell us that 2 is a solution to this problem. There will be times when you will get something that is false, and when it is false, you'll just simply say that it's no solution. Hopefully this helps you if you get stuck at home and you're not sure, like, what am I supposed to do again? Pause it, replay it, do it as many times as you need to, and good luck. We'll see you in class. Bring your questions.